Welcome back. This is part 2 of the custom.NET Core Server implementation. You would have noticed in part 1 that I just brushed across a whole range of topics. In part 2, it's actually even more topics. So I'll be showing you enough to just get your tip wet. You'll have to go and Google it if you want to know more, which I suggest. But yeah, let's just get stuck into it. So the first thing I would like to do is change something that I did in the previous one. So in the previous video, in my HTTP client, we're using the Json utility here, which is the inbuilt Unity one. After I released the first one, someone in my Discord mentioned, why don't I just use Newtonsoft also in the game as well as the server? And very valid point. I don't know why I didn't think of it. So in your Unity game, go to your package manager and go add package from Git. And Unity actually has an official version of Newtonsoft. So we can just add that directly. And I'll put that in the description if you need to copy it. And once that's in, we can just change this line here to just JSON convert. And this will be deserialize, and that will just be of type T. And we can just put in the same parameter here. And let's copy that also for this part. There we go. So we've just changed it to Newtonsoft now instead of the default one, which gives us a lot more freedom. It means back on our server, we don't actually have to make these fields. We can actually have these as properties. So let's actually make them properties because it's quite beneficial, especially in the later stage, which requires properties. And one last thing to just clean that up, we don't actually need to use this. If you remember, this line here made the models return as Pascal case. So let's just remove that, and that is it. Okay, so the first thing that we're going to tackle today is a database. And the way we're going to do that is by using an ORM, or an object relational mapper. And effectively what that means is you can play with the tables and rows in your database as if they are objects in your project. So we could have a player table in the database, and we could just query it and use them just like it's played here. And we don't actually have to do direct database queries for the objects, which makes it much easier. So in .NET Core, the most popular ORM is actually one made by Microsoft called Entity Framework. So the beauty with Entity Framework is it works with a whole bunch of different databases. And I know people are divided on how they say this word, but I call it SQL. You can use MySQL, you can use SQLite, you can use Postgres, you can use a whole bunch of them, okay? But for this one, I'm going to use just MS SQL. And I've got a database hosted up in Azure. So let's install that, right-click server, manage NuGet packages. I'm just going to search Entity Framework. So as you can see here, there's a Postgres one, there's a SQLite one. I'm just using the SQL Server one. Make sure you choose the one for your framework. I'm using 6. Install that. And there's also one more thing that we need to install, which is Design, and I'll tell you about that in a moment. So just make sure you install Entity Framework Core Design. Cool, so what do we want to store in our database? And I think the first thing that we should store are users, because the next part of this tutorial is actually authentication and authorization, so we need users. So in our shared library, let's create a new class, and let's call this user. And in here, I'm going to create a few props. This one will be a username, and this next one will be password hash, and this next one will be a salt. Whoops, salt. And actually, we do need a ID. So I'm going to use an integer for an ID. And I'll tell you what these are in a moment if you're unaware, but let's just continue setting up. So in server, let's create a new file, and it will be a class, and I'm going to call this game DB context. And in here, I'm going to derive from DB context. Now this is going to be a little bit of word spaghetti for you, but just bear with me. I'm going to create a constructor here. And in this constructor, it's going to take a DB context options. And this will be a generic type, and it's going to take in the actual DB context options. And we also need to call the base constructor here. So what this class is, I guess you could think of it as your gateway to the database, right? It's how we deal with our database using our ORM. And in here is where we also declare what is going to be in our database. So we could make a prop here, and this will be of type dbSet, which is what we use to call one of our tables in a database, and we'll use our user, and this will be of type users. So now that we have our gateway for our database, we need to actually tell our application that we want to use it. So in program, we want to inject another service. So let's do it up the top here. Let's say builder services. And the good thing about this, so when you're creating your own services, you can just use, like add scoped. But there are built-in types which do a whole bunch of setup for us, and one is specifically for entity framework. So let's do add DB context, and this will be our game DB context. So this is very generic at this point. It's just a standard entity framework class. What we do in the options here is to say, hey, we want to use SQL Server, and this is the connection string to connect to our SQL Server. So we'll just do an options here, and this will be options, use SQL Server. So that's the SQL Server package that we installed. And now we need to actually get a connection string. So hard coding connection strings and any kind of secret in your application is a big no-no. So there are many reasons for that, but just imagine you're working with a bunch of people on a project and not all of them are meant to know the secret, and you've just committed that to GitHub with the hard coded secret. There are a million reasons, but that's just one of them. So what we can do is Builder here gives us access to a configuration file, which I'll show you in a second, but let's just do this. Builder, configuration, get connection string, which is already built in, and we're just gonna call this DB for now. So we're grabbing a DB connection string. Now, where does it get that from? And that is from this file here called app settings, right? We've got app settings and app settings development. Okay, so in app settings, let's make a little section here called connection strings, and have a property in here called DB, and let's just make that equal to a blank string. The reason I make this a blank string is because when we actually deploy this, we can put environmental variables on the deployment, like on the virtual machine or on the dedicated web app service, like maybe on Azure, and that will actually inject information here. So we don't actually need to put it here, but while we're actually developing, obviously we're not wanting to put environmental variables left and right. We've got this app settings development. So this file here is completely ignored in production, but it allows us to actually put temporary variables while we're developing. So I'm not going to show you how to set up a database. And even for development, I actually use cloud-based databases simply because I swap from computer to computer and I always want my same test data wherever I go. It's just easier. So I'm just going to use a long ass connection string, which is for an Azure SQL Server. So yeah, go set up your server, put your connection string in here, and then continue with this tutorial. And just heads up, these concepts are the same across all platforms. You're learning right now for .NET Core, but this concept of an app settings will be in a Node server, it will be in a Rust server, a C++ server, it will be in all servers, just possibly named different. But because you're learning this concept, it carries over. So it's valuable regardless of the framework that you're using. And that is all we need to do to set up our server. So you may be wondering now, how do I actually put my tables on the database? And that is the sexiest thing about an ORM, is that you can do code first migrations. So we create the code here, and then we actually push it to the database, and we never have to manipulate the database manually, ever. If you're using an ORM and you're finding yourself manipulating the tables manually, you've done something wrong. Take a few steps back and do it the proper way, or else you're gonna get syncing issues and it's gonna be an absolute fucking nightmare. So depending on what database you're using, you'll have a different database explorer. But for me, I use Navicat, and I've already added my server here. So I'm just going to go in here and into the actual database. So with the Entity Framework, it's very easy to push our models to the database. Just go to the root folder of your server, open up a command window. I'm using PowerShell, and in here type .NET EF, as in Entity Framework, migrations, add, and I'm going to call this the initial commit, or the initial migration. I don't think we're passing in our options. So here I'm calling the base, but it actually needs to be sent in with options. Whoopsies. So now that will, what this is doing is we're sending in here this configuration, it's sending it through to here, and then we're sending it to the base class with the options, and then Entity Framework can set itself up. Sorry if that was confusing. Let's actually just clear that and do the initial commit again. And yeah, so it's done. So now we'll have this migrations folder here with this initial migration, and you'll see here on the up, so what we're pushing to it, it's found a users object in our DB context, right? So now it's writing everything to scaffold the database. So now we've made that migration, we need to say .NET EF database update. And what that will do is it will look through all the migration files. It will look through all the migrations on the database, see where we are in the queue, and then sync the rest of them that we have not already synced. And that's it, pushing all the tables. And now if we go to Navicat, we'll see that we've now got a users table with all of our things. And if we ever wanted to change this table, we would literally just change it on our thing here, make a new migration, .NET update, and then it will automatically push it for us. And we never have to change the database tables manually. Cool. And now if we want to actually use it, use the database context, let's go to our player controller here. And if you remember, we actually added it in our dependency injection here, which means we can just simply inject it straight here. So let's add a game DB context. We'll call this context. Now here we'll make a global variable like that. Cool, so we've got our context here. Now in our get function, just to test, actually no, we'll just do it straight in the constructor. Now to add data to your database, let's just say user equals new user, because that's the only table we've got right now. And let's just say the username is Taro and the password is password 69, baby. And then here we'll go context.add and we'll send in our user. We've told the framework that we want to add something, but we haven't committed it yet. So to do that, we say context.savechanges. And actually, before we run it, I know that salt is a non-null value. And also, if you remember, there's an ID here. Now, ID, if you name it ID specifically with an integer type, Entity Framework will use that as a keyword and it will auto increment the ID automatically. So this will be the first thing in the database and it will probably have an ID of 1. Insert another one, it'll have an ID of 2 and they'll never clash. They'll just keep going. And that is a very quick way to index your models. But there are a few security concerns there, but I'll possibly touch on that a little bit later. So anyway, let's press debug and let's go to our endpoint. That's a high level. So here we've made our user, we're adding the user to the context and we're saving the changes. Cool, so it's done. So now if we go across to here and I refresh my models, we'll see that it has indeed inserted that object. So that is how you use your DB context. You just inject it into any of your files and you just add it to the context and save changes. All right, so that was just about the quickest rundown of Entity Framework in the whole world. Let's move on to authentication now. All right, before getting stuck into actually implementing, we will need to be storing more secrets. So for connection strings, it's good to have this connection string object, but for other project-wide settings, make your own little settings object. Makes it nice and easy. So I'm going to have that and I'm going to be calling this a bearer key. And I'll show you what a bearer key is in a moment. So if you remember, this is in our app setting. So this is production. So I'm not going to put a value here. I'm going to go over to my development settings. And for the value, I'm just going to put some password here. Obviously, the more secure, the better. And now to easily use our settings in our application, let's make a model here. Now, this is never going to leave the server. So let's actually just create a new folder on the server called models. And in here, I'm going to create a new class, and this is going to be called settings. So make sure that it's named exactly as you have named your settings here. And we've got a bearer key in here. So I'm going to create a prop string bearer key. Now, what would be good is if we can automatically bind this to our configuration and then inject it so we can use it anywhere in our application. So that's quite easy to do. After our builder here, let's go var settings equals new settings. Woo. Settings. And then to automatically bind the configuration, we can do builder configuration bind. And in here, we'll say we're binding settings to settings. So that will do some magic in the background to automatically go through our configuration, find the objects and bind it all. And then we need to actually inject this into our services. So let's go services, add singleton and just send in settings. Cool, so now we can use this settings object anywhere we want. So to authenticate our users, we'll need a new controller and let's call this the Authentication Controller. And to save a bit of time, let's just copy some scaffolding from player controller. I'm going to put it R2 and this will inherit from controller base. Cool. All right, so that's our controller there. Now what this controller is going to do is accept login and registration requests. So let's create a HTTP post. This will be public void register. Now, one thing to note, if you've got multiple endpoints in a controller, so let's say I've got something here, and this is called something completely different, but this one is a HTTP GET. So both of these endpoints will actually be accessed from the same route. It will just be /authentication. It's just depending on if you're getting or posting, it will go to that different route. But if you've got two endpoints which are both post, which is what we need to have right now, you need to actually declare the route. So in here, I'm just going to say that this one is to register and this one is to login. And as we are making an API, it is good practice to actually return proper types. And an easy way to do that in ASP Core is to use this special interface here, iActionResult. And that allows us to actually return proper HTTP codes. So for example, we could just easily return an OK, which will be a 400. We could return a bad request. We could return unauthorized, for example, and this will automatically return the proper error codes. And also we could insert some data there too, just to give them more information. So let's actually do this controller properly and the way that you should do it. So if you remember, I showed you how to create a service and inject it, which is actually what you should be doing in controllers. So I like to abstract as much logic, business logic, from the controller and put it in a service. That way it's modular, it's easy to test, and really I think it is the best way to do it. I know I didn't do it in the player controller, but that's because the last episode was like so all over the place. I did so many different things, but let's actually do it properly here. So let's make a new class in services. I'm going to call this Authentication Service. Now, authentication is a massive topic. Honestly, I could make a 10-hour course on it and we would still have a million gaps. So I'm not going to type it all out manually right now. I wrote something off camera. It's the simplest authentication service that I could possibly manage. So I'm just going to paste that in here and we'll add the references. And then let's go over it step by step. So first up, I have made this iAuthentication service. So that is just the interface. So that will allow us later, if we wanted to make a mock authentication service for testing, right? And really the only functions in it are register and login. That's all it's handling. Obviously there's a bunch more to it, but okay, let me just make this a little bit bigger. Okay, so in register, we're simply checking if the username is available. If not, we're returning false. Next, we are creating the user object, and as you can see, we're setting the password, which will actually be the plain text password that the user has provided, and we're setting it to the password hash right now. Now, I'm sure you've heard, never store plain text passwords in your database. Now, that is for a million reasons, but the first one being that if anyone actually finds out that you're storing plain text passwords, they'll call you an absolute galah. And really, it's just super disrespectful to your user base because not only is it making them vulnerable on your website, it's also making them vulnerable on everybody else's website that they use. People shouldn't, but they reuse the same password across multiple websites. So if someone has signed up to your website with their email address and password 69, for example, and someone hacks this password, they've now got that plain text password. They can now try thousands of different websites with that email and password, hoping that they have reused that password. So as I said, super disrespectful to your users. It's super unsafe. Never do it. So to get around that, what we do is we take the plain text password, right, which I have done here, and set it to the user. And now I've got this function here, provide salt and hash. So let's just go have a look at that. Now, you don't need to understand what's going on here. Okay, so you can download this code and use it and dissect it yourself. But what we're actually doing is we are taking a plain text password and we are running it through a hashing algorithm, specifically SHA-256, HMAC. And what hashing is it is a one-way function. So you take a bit of data, you hash it, you get a garbled piece of data, and it is impossible to get that data and take it back to the original source, right? So now what we have is a unique piece of data, which actually does act as the password. We just don't know what the original password was. It's just a hash piece of mess. Now, this isn't foolproof by any means. If a hacker gets your database, they can now run an offline brute force attack, basically trying every single combination of word, letters, and symbols until they find something that is identical to your hash. Now they know your plain text password, and yeah, so then we're back at ground zero. The moral of the story is don't let your database get hacked, but this is the lesser evil way to store passwords. But there is still another vulnerability. For example, what if you're using password 69 and the hacker brute forces that and they get your plain text password? What now if 10 other people in your application are also using password 69? Their hash will be identical to yours, right? So he's now hacked 10 people for the price of one. So to get around that, we generate a salt for each user. Now the salt doesn't necessarily have to be private, but obviously it's better to keep it private. Now what the salt does is it adds flavor to the hash. So every user hashes the plaintext password plus the salt effectively, and it now gives 10 people who originally had the same password 10 different hashes. Okay, so now hacking one person doesn't actually hack 10. So I hope that all made sense, but to summarize, password hash is just a more secure way to store a password. So now that we have our user and our user has a salt and hash after this function, we can now just add it to the database, return true, you have been registered. Excellent, you can continue the flow. Then we've got our login function. So yet again, this is the plain text username and password that the client has just sent us. We check to see if there is a user with that username. If not, we return invalid username. Now, this is another security vulnerability. I'm just doing it to showcase it. You should always just say you have entered an invalid username or password. Because if they're brute forcing, trying to find a username, you're going to be returning invalid username, and then finally you're going to be like invalid password. And they're like, okay, I found a username at least. And then they can start brute forcing the password. So it's just more information. I'm returning this from the service so that in the controller, you can log it. Oh, this person entered an incorrect password. But ultimately I would be returning to the client incorrect username or password. So anyway, if the username is available, we are now comparing the password hash in the database, and then we are performing the hash again on the plaintext password to compare them. And I will show you what a hash looks like in a moment when we actually make a real user. All right, so if the password checks out, we now come down to this last line, which is generate JWT token. Now, if you don't know what a JWT token is, you are lucky, because I'm about to introduce you to what I think is like the coolest tech ever invented, really. So it's a super simple concept. Basically what it is the server gathers a bunch of information about the user. For example, what permissions he has. If it's an application, it could be, does he have access to these documents? If he does, can he read? Can he write? If it's a game, it might be, do you have access to these heroes? Do you have access to these guild privileges? We put all of that in a little package, including the user ID, possibly. Once we've compiled all that information, we then sign it with a symmetric secret key, which is actually our app settings here, what we're putting here. So what signing is it's effectively putting your signature on a package to say, hey, we've read these bytes and this is our signature for these very specific bytes. So then you're left with this long ass string, which is actually a JWT or a Json Web Token. So this obviously looks like gobbledygook, but you can actually decode it into plain text, and anyone in the world can do this. They can just grab it and decode it. So on the client, for example, say you've got you've logged into a website and on the sidebar, you've got the logged in username. They will actually be grabbing that from this Json Web Token and putting it there, right? So they don't need a database call every single time to say, hey, what's this user's name? It's just right there in the token. And then also when the client now is making a request to the server for some kind of protected route, something that requires you to be logged in, and also something very specific to this user. So if I want to edit the inventory of my hero, for example, I will post to the inventory controller and I'll send through this JWT with the request in the headers. And on the server will now check in the JWT, hey, does this person have access to this hero? Can he do this inventory management? If yes, then perform it. Right? So that means that the server doesn't actually need to make a database request to check this person's permissions, because it's already in this token that has been sent. So you might be thinking, okay, but if this token can be changed to plain text, what's stopping me from editing the token and sending it through? Well, nothing is stopping you from doing that. But because the server has signed it with his symmetric secret key, you don't have access to that secret key. So you've now changed it. You've changed the bytes, which doesn't match the signature anymore. So the server can now say, fuck you, that's invalid, and not serve you the request. So yeah, I think it's amazing tech, and it's used everywhere, like everywhere. Every single website uses it. Bunch of applications use it. It really is the standard today. So yeah, that's what a JWT is. Now, just to see how it's actually compiled, we've got here, generate the JWT token. As you can see, we're grabbing the bearer key from the settings, and we're just making it a key here. And then these are the parameters of the security parameters of the key. And we're basically just saying, this is our signing credentials. This is what we're using to sign it. So we're using our symmetric key here. I'm saying it's expiring in 10 years, which is not good design. Really, you should have a really short expiry time, and you should also be generating a refresh token, which allows them to just say, all right, my token's expired. Here's a refresh token. Can you please give me a new token? And you just like keep doing that over and over. I'm obviously not doing that for this tutorial because that will be way too long. And it's also asking for a subject. So this is the data that we're chucking into the token. Right now, I'm just saying, I'm just gonna add an ID, which is the user ID into the token. That's all we're adding right now. And then we actually just create the token, and then now we're returning it. So this is the simplest authentication service that I could possibly make. I abstracted as much as possible. So now back in our authentication controller. So it's good practice if you've got a bunch of information that needs to be sent or received from the server, you should create a model for it. So this needs to be shared across the client and the server, obviously. So let's make a folder in shared library. Let's call this requests. Whoops, requests. And then in here, let's make a class, and this will be called Authentication Request. In here, let's make a prop. This will be string username, and this one will be a string as well, and a password. Cool, so in the authentication controller, this will be accepting an authentication request, and this one will also be accepting the same thing. And we actually need the authentication service, don't we? So let's make a constructor, and then in here, we'll accept an authentication service. This will be auth service, golly gosh. Auth service is equal to auth service, and let's make that a global. And then in here we'll be saying result of the authentication or the registration will be auth service dot, and that is not what I need. What is this? It's a Microsoft class. So I've named my authentication service the same as theirs. I'm going to remove that namespace and then actually add my one, service authentication. Hopefully that doesn't screw any of you guys up. So in here we'll go register, and we will send in our request.username and request.password. And this is a tuple that we can actually explode. So deconstruct it, success and content. And then we can just say if success, or sorry, not successful, we will return a bad request, and we'll send in the content here because that will actually be the error. It will say username is not available. So username is not available is a necessary evil. So obviously you don't want to tell them that someone else has that username, but you also need to actually tell them that they can't use the username, right? You could use the same error for if they're using hyphens and shit in their username and they're not allowed to, but really we do have to say username is not available. And I think it's always good user experience that when someone registers, you automatically log them in. I know a lot of applications and websites don't do that. You've got to register and then they take you to the login screen. So what I like to do is just straight away return login, and then I'll send through the request because, hey, they've just registered. All right, cool. So may as well just log them in straight away. And in login, it's actually very similar to this. So let's just do this. And in this, we'll go login instead. And then finally, we will actually return let's make a new model here. And this will be in a folder called responses. And I'll call this authentication response. And for now, this will just have a string and it will be of type token. And in here, we're going to return an OK, which is a 200 response. And we'll say new authentication response. And we'll say the token is equal to the content. The content could potentially be an error, or it could be the actual token. And just depending on the first parameter, true or false, is what it is. So as I said before, you should not actually return incorrect password or incorrect username, but it is good to return it to here. So then maybe you can do some logging to your end to say a user has logged in, because that's a good way to catch someone brute forcing, right? So that's actually it for the controller and the authentication service. I know it's a lot, but I hope that you're sucking it in and you're learning. I just realized that we haven't actually added this to our DI. So let's go across here and we'll go down here, builder services, add scoped, authentication service, and then the concrete class will be authentication service. Cool, because that would have thrown an error. Okay, so let's actually remove this user that I had in there so that we can do it properly. Let's actually fire this puppy up and register a user. So let's get that up and let's start up Postman. Cool. So we know that it is a post request and it's not the player controller, it's the authentication controller. And register. What does it accept? What have we got? It accepts a authentication request, which it just is an object with a username and password. So in our body, let's go raw JSON, a little object here. Let's call this username, and this will be tarot dev, and password subscribe to me. Wink, wink. Okay, so if we send this, beep, and it has returned a token. So if we look into the database, first up, you can see that it's an ID 3, right? Because it's constantly counting. And just because one record was deleted doesn't mean that that ID is relinquished. It will just continue going. You can see that we've got the salt here, which is just gibberish, and a password hash, right? So password hash is the plain text plus the salt through a hashing algorithm, and that's what we've got there. And now that this registration, and also if you remember, I automatically log them in. So if we actually did that, we could just say login and send the same details, it will log us in. Okay, so there's this cool site here, jwt.io. So if you just grab your token in its entirety, and go down here and just plug in your token, you'll see that it just decodes it into plain text effectively. It's got a few things that we didn't specifically put in, but like the expiration time of our token, which is 10 years from now, so you won't even have to worry about it. This is the data that I put in, if you remember, the claims. Where are we? Authentication service. I just put in that there, the ID. So now the client has the JWT token. What can we do with it? So what we've done so far is called authentication, right? The process of logging the user in. Now we're moving on to authorization. So now that the user's logged in, what do they have access to? What are they authorized to do? And I just want to change something else just to make it a little bit easier to work with. So we've got this player controller here. I would prefer to make this a heroes controller. So every user has multiple heroes, for example. It's an MMO. So let's actually change this. Let's change hero player controller to hero controller. Hero. Yep. And then let's actually change the player object to hero. Cool. I think that's it, right? We don't actually have this in our database yet. So in the user, let's say we want a relationship between user and hero. So we want the user to be able to have multiple heroes, and that is called a one-to-many relationship. So what we can do is we can create a list here. This will be of type hero. And then on the hero object, you will have a property here called user. Right? So on the hero, you've got a user object, and on the user, you've got a list of heroes. So it's a one-to-many relationship, and Entity Framework will look at this and it will automatically set up the relationships for us with foreign keys. So what we'll do is we'll go to our server and we'll say a new migration. We've added heroes, and then we'll do just the database update. Cool. So now if we go to our database, we will see in tables, if we refresh it, we've got now heroes, and you can see here that Entity Framework, even though that we put the user here directly, we'll see that it has changed it and put user ID. So they're picking up these and using them as foreign keys. which is super duper handy. So we now need to add authentication and authorization middleware to our application. And because we're using JWT specifically, we need a little package here. And this will be a sub package of the ASP core authentication pipeline. So authentication .jwt bearer. So as you can see, there are a whole bunch of schemes. So you could have authentication using a third party like Google. Like for example, if you've ever gone to a website and signed up to that website using Google or GitHub or something, that's what this is. You can also implement full-blown OAuth and OpenID Connect, which is like what we're doing now, but at a far bigger extent, right? And that also actually allows you to offer third-party services. So now you can become Google and people can authenticate using your service. But obviously that is way out of scope. We're just going to use JWT Bearer. And make sure you always pick the one for your correct framework. Now, after all of our services have been added here, let's add another service, builder, services, add authentication. So this is where we put the scheme that we're wanting to use. As you saw before, there's all those different schemes like Google and all that. We're using bearer, but obviously strings suck. So because we've got that JWT bearer package installed, we can do JWT defaults, authentication scheme, which as you can see when you just hover over is just bearer. It's just a constant. And now we need to actually configure it. So add JWT bearer, and in here is options. And now this is like the accompanying part to the JWT token generation that we did. So if we go into our authentication service, we'll see this is our JWT setup, right? We're saying we're using this signing key. It's expiring whenever. So this is like the accompanying part that validates those settings. So here we'll do token validation parameters equals new token validation parameters, issue a signing key equals new symmetric signing key, and we'll need to encoding, ASCII, get bytes, and then we're actually sending in our key here, and we've got our settings object here, so we can just say settings.bearer key. So now I'm actually going to tell it what to validate and what not to validate. First, we want to validate the signing key, issue a signing key. So we want to say true to that. Now I'm going to actually disable a few things, a few checks. Validate audience, I'm going to say false. So the audience is, it actually checks where the client is coming from and if it's a valid domain. If not, it will reject it. I'm not going to do that, obviously, and not everyone can actually do that. For example, some services have no idea where the client's coming from. And I'm also going to turn off validate issuer as well. Okay, so that is our validation. So that is the yin to this yang, basically, the issuing and the validation. Okay, next in your pipeline, make sure you've got app, use authentication. Cool, so now we've scaffolded authentication and authorization, and now we can just use it. So in our hero controller, let's assume that we only ever want people to call this once they're logged in, right? We should never let someone get or post a hero if they're just some random and they're not even logged in. And because we have scaffolded our authentication here, we can easily just ensure that this is an authorized route by adding a little attribute here called authorize. And now, unless someone has the bearer token, the JWT, in their request, they'll never get through. And we've got player service here, even though that we're not using the player service, but iHero service, let's just change that. And yes, I should be abstracting this business logic into the hero service, but I'm not going to do that for this tutorial because it's already super long. But you know how to do it from the authentication service, right? So let's leave this get function for now. Let's change this post function. So we want a logged in user to be able to post a new hero. So let's make a new request here. Let's add a class and call this post. Let's call it CreateHeroRequest. And this will just have, for example, a name for the hero. Whoopsie doodles. A name for the hero. And actually, what do I have on hero? ID, level, health. That kind of sucks. Let's remove those actually. Let's just have a prop string, and this is just the name of the hero. And I suppose we'll also have an int for the level. And we have to migrate again. So changed hero, added name to hero would have probably been better, right? But what else? And push it to the database. Cool. All right. So now in our hero service, we're going to accept here a CreateHeroRequest, and we'll call this request. The cool thing is we have this JWT that was just sent to us, and we can grab the ID of the user directly from that JWT. So let's do this. Let's say user ID is equal to, so this part is a little bit confusing, but ASP Core has a construct called user, right? As you can see here, and it's a capital U, and it is of type claims principal. So what adding authentication here does is when the request is actually sent, it will grab the bearer token and construct all the claims that we've put into it. So, and that is in this claim, this user object here. So user.find first, and the claim that we're looking for is just ID, right? That's the one that I put in there. And we know that this is going to be present 100% of the time if it gets to this, because we've got this authorization header. So we don't need to check it for null or anything like that. We can just do int pass, and let's put that there. And we actually need to grab the value from that claim. So it's saying, hey, this could potentially be null, but it will not be null. So now that we've got the user ID, and this person is sent through the CreateHeroRequest with a name, we can say var hero equals new hero, and we can say the name is from the request.name. And let's assume that you only want the character to the user, each user to be able to create 5 characters each. Like you could grab the user here. You could say context.users.first ID equals user ID. So yeah, Entity Framework or any ORM allows you to query the tables just like their objects. See, I'm using link here to query my users for the first one that has that user ID. And then here we could do some extra validation, like how many heroes has this user got? So right now this is just grabbing the user, but if we wanted to grab all the heroes as well, we could say include and then the heroes list. So this object now will be the user and the list of all their heroes. So we could say if user has more than 5 heroes or whatever, reject. So now in our new hero, we can say user is equal to user. And then in our context, we can say add hero, and then context, save changes. Cool, and then we'll just return the hero, because that's obviously, if you've got like a level select screen and you've just created a hero, obviously you want the hero now to be returned so that you can show it on the hero select screen. So let's actually test that, right? We logged in before, but let's actually log in again so that we can grab this new token, even though that the expiry was 10 years. So let's just grab that. And let's make a new post here. And this will be not to authentication, but to the hero controller. And it will be a post. And in the body, if you remember, we are sending through the CreateHeroRequest, which is just an object with a name. So let's make that. This will be name. And let's call this Taropus, which is what people in my Discord call my little octopus.
And if we try to post this now, it'll say unauthorized, right?
And that's because we're trying to access this authorized controller and we haven't put in our JWT. So to add our JWT, we go to headers, and this will be of type authorization, and the value will be bearer, right? Remember how we set up that bearer scheme? So this one down here, let's just copy that and put that here. And now if we press it, and still unauthorized. Oh, I missed a character. All right, that should work. That didn't work. Self-referencing loop. What this is saying is we have a relationship, so the user and hero, and basically what's happening is that probably did actually create the hero, and then it tried to return the hero to us, but there's a loop between them. So the user references a hero, and then the hero references a user, the user references a hero, and it just like goes on and on and on. So we can fix that. We need to say serializer settings, referencing loop handling equals, and then we'll just ignore it. And that should work. Let's restart our server. And actually, it kind of sucks because that probably actually did get created. Yep, so it did actually get created, but just for the sake of this, let's actually make another one, and we'll call this just Tarot. I'm not very imaginative. And there we go, it did actually create. And as you can see, it has returned our user in its full glory with its password and salt and everything, which is obviously not what we want to do. Now, there are quite a few ways to deal with this. One, we can make this completely not serialized, so it just never gets sent to the server, to the client, sorry. We can create data transfer objects, so we don't ever send hero and user, we send hero DTO and user DTO, which is basically the stripped down versions of what we want to send, and that's what we send. But for now, I'm not going to get into all that. I'm just going to say, before we return this hero, we're going to say hero.user equals null. And then that will just return just the hero. That's cool. We're now creating heroes, and all they're sending through is the name, right? And we can infer who they are and who to link it up to because we've got this user ID. And obviously, once you're actually creating your application, you might create a helper class or a base class in between these two, which will allow you to easily just say, you know, like user ID, and that will automatically hook that up for you. But for now, I'm just having this inline. Now, the very last thing I want to show you is some more advanced authorization. So say this is not a get, say this is like edit a hero, right? And we're sending through the hero ID, but also from body, we're sending through let's just send the create hero request again. So let's just say we're wanting to change this hero with ID to a new name, but we don't know if this person has access to this hero. So what we can do is, when we are creating our token here, when we're grabbing it and generating our token, we can say, let's include the heroes with this. So now we're grabbing the user and the heroes, and down here in our claims, we'll add our ID, and we'll also add new claim, and this will be heroes. And what we want to do here is serialize a list of all the hero IDs that this person has. So we can say user, heroes, select, and let's just select the IDs, right? And we want to serialize this into a list. So let's do Json convert serialize object. And let's just start the server just so we can see that. So if we go back to our login and log in here, and let's grab this and decode it. So back to our decode here, and we can see an array here with two IDs of our heroes. In our hero controller, we can say var hero IDs available to be able to edit or whatever. We can say user find first, this will be heroes, and then the value. But we know that we want the value to be a list, so we can say JSON convert deserialize objects. Let's make this a list of ints, and this will go there. So now we've got, directly from the JWT, we've got a list of hero IDs that is allowed to be edited. And then we can say if hero ID is available contains this ID, or should I say does not contain it, we can return unauthorized. Unauthorized. This should be action result, and then this should be unauthorized. You do not have access to that hero. And then here we'll actually change it. So we'll say, we'll grab the hero, we'll say var hero equals context. Whoa, heroes. So in our DB context, heroes is in the database, but it's through this relationship. You can actually add hero here. It is so noisy outside. So now we can say heroes directly, first h hero, where ID equals the ID here that we're wanting to edit. We can say hero.name equals the request name, context.save changes, and then we can just return, okay, you have successfully changed your hero's ID. So let's just try that. Let's put a breakpoint here actually. So here we want to do this, and then /, what's an ID that we had? ID 1. And then in the body, let's name this to Tarot V2. I think that should be, yeah, let's try that. Method not allowed. This is actually meant to be a HTTP post. And I actually forgot to migrate that change that I added heroes to the actual DB context. So I'm just going to do that. And database update. Cool. And let's debug that. So I'm going to grab a new token. Let's log in again. Grab a token. Put it in this. That will have our updated hero list. Let's try that. So let's hit our breakpoint. Let's come here, and if we hover over our user and see our claims principal, we'll see it's got a bunch of claims, and one of them is our hero IDs here. So let's continue. It's going to check to see if this ID, 1, is in our list of hero IDs, which it will be. It's going to grab our hero, change the name, save it, and return OK. And we are all done. Okay, so that's the end of this one. I didn't even get into the authorization claims-based and roles-based policies, but I'll put a link down in the description about that. That is a fundamental part of authorization. It's obviously a huge topic, and I'm exhausted just after this tutorial. But yeah, I hope you found this helpful and fun. I'm gonna put this entire project up on my Patreon, so you can just download it and you'll have a game and a server ready to go straight away to start editing. I'll also put a whole bunch of comments through the code to suggest where you should go from here. So yeah, like the video, subscribe, and if you guys wanna see a video on deploying maybe, let me know. But I think I'll wrap this up here, and yeah, I'll see you next time. Bye.